Hello, students! Today, we're going to explore the world of chemical reactions. Now, this might sound like a very big, complicated topic, something that only happens in a science lab, but the amazing thing is, chemical reactions are happening all around us and even inside our bodies every single moment. So, what are they, really? Have you ever just paused for a moment and thought about the little changes you see every day? Have you ever wondered what is really going on at a scientific level when things around us change? Think about it. When milk is left out for too long, it turns sour. The taste, the smell, it's completely different, isn't it? Or when a shiny new iron nail is left out in the rain, it gets covered in that reddish-brown flaky rust. When your mother cooks food, the raw vegetables become soft and they get a new taste and a new smell. The food we eat, it gets broken down inside our body to give us energy. And even when we just breathe, that's a chemical process too. In all these cases, one thing is the same. Something old is gone, and an entirely new substance has been formed. So to really understand these processes, we first need to be very clear about two different types of changes. This is a very important distinction to make. We call them physical change and chemical change. So, what is the main difference? Well, in a physical change, the substance might change its shape or its size. For example, if you tear a piece of paper, but it is still paper, right? No new substance is created. But in a chemical change, the story is completely different. The identity of the substance itself changes. A totally new substance with new properties is formed. This is the most important idea to remember. A chemical change makes something new.
Now, a very good question that often comes up is melting ice a chemical change? Well, let's think about it. Ice is just solid water. Its chemical formula is H2O. When it melts, it becomes liquid water. But what is its formula? It's still H2O. The substance itself has not changed. So remember this carefully. A change in state, like melting or boiling, is only a physical change.
Okay, so whenever a chemical change happens, we can say that a chemical reaction has taken place. They are really just two ways of saying the same thing. A chemical change is a chemical reaction. So let us now define this properly. A chemical reaction, it's like the story of a transformation. It's simply the process where some starting substances are changed into completely new, completely different substances. You start with one thing, and you end up with something else.
Every story has a beginning. The substances that we start with, you can think of them as the ingredients for the reaction. These are called the reactants. They are the materials that are going to change.
And at the end of the process, the new substances that are created, the final dish that you get, these are called the products. So it's very simple. Reactants turn into products. Let's look at a simple example to make this clear. When we burn a magnesium ribbon, it uses oxygen from the air to burn. So here, our starting ingredients are magnesium and oxygen. These are our reactants. And the new white powder that we get at the end is called magnesium oxide. This is our product. You'll notice the arrow always points away from the reactants and towards the product. This leads us to a very practical question. Let's say you are in the lab or you're just watching something happen. How can you tell if a chemical reaction is actually taking place? What are the clues? What are the signs we should look for? Let's find out. There are 4 main observations that help us identify a reaction. These clues are a change in state, a change in color, the evolution of a gas, that means a gas is produced, and finally, a change in temperature. Let's look at each of these signs one by one with an example. So our first sign is a change in the state of the substance. This just means that you might see a solid turn into a powder, or perhaps 2 liquids mixed to form a solid. The physical form changes because a new substance is being made. Let's go back to our magnesium ribbon example. I want you to imagine it. We start with a solid, flexible, metallic ribbon. But after we burn it, what do we have left? We have a fine, white, ash-like powder. So the state has changed from a solid ribbon to a solid powder. This is a very clear sign that a reaction has happened. All right, our second clue. And this one is often the easiest one to see. It's a change in color. If you notice the color of the substance is changing, it is a very strong hint that a chemical reaction is taking place. Let's think about that magnesium ribbon one more time. What was its color to begin with? It was a shiny, silvery gray metal, wasn't it? But when it burns, it makes a brilliant, dazzling white light, and the powder that is left behind is also pure white. So this change from silvery gray to white is our second definite clue. Our third clue is the evolution of a gas. What does this look like?
Well, during a reaction, you might see bubbles or some fizzing. This is a sign that a new substance is being created in the form of a gas. I want you to picture this in your mind. Imagine you are in the lab. You take a few small gray pieces of zinc metal, we call them granules, and you drop them into a test tube that has some acid in it. What would you see? Almost immediately, you would see lots of bubbles forming all around the zinc pieces. That fizzing you see is actually hydrogen gas being produced. A new substance, a gas, has been made. And now for our fourth and final sign. This is a change in temperature. A chemical reaction can either release heat, which makes its container feel warm, or it can absorb heat from the surroundings, which makes the container feel cold. Here is a very common example. Imagine you take some quicklime powder in a beaker, and you slowly pour some water on it. You would actually hear a hissing sound, and if you carefully touch the outside of the beaker, you would feel that it has become quite warm. Why? Because the reaction is releasing heat energy into the beaker. So, we have covered some very important ideas today. We started with examples from our daily life, and now we know how to identify a chemical reaction. Let's just take a moment to quickly summarize the key points. So the most important thing to remember is this. A chemical reaction is a process that always forms a new substance. It starts with our ingredients, which we call reactants, and it ends with the new substances, which we call products. And to know if a reaction has happened, we can look for our 4 clues: a change in state, a change in color, the evolution of a gas, or a change in temperature. So now we know how to spot a chemical reaction. We are like detectives, we know the clues, but in science, we need a way to describe these reactions properly, a way to write them down that everyone in the world can understand. So how do we write the story of a reaction using the language of science? Well, that is exactly what we will learn about next time when we study chemical equations. Thank you for listening.